And myself as well. Great.
So this is who we are. My name is Alexis. I work at KUKA Robotics here in Michigan, Shelby Township. I am responsible for the KUKA College. KUKA College is a training center. We're responsible for teaching people how to use robots, our customers and our own employees. So it's a very nice job we got there. I have a robotics and automation mechanical engineering degree, and I've been with KUKA for about 16 years and in the robotics industry for about 18 years. So yes, I'm very orange. This is my colleague, Michka.
How y'all doing today? So I am an engineer with KUKA Robotics, and I focus on the medical field. So we'll get into that a little bit later, just as a little snippet so you guys can see that we don't just do automotive. We also have some other fields that we're really interested in. I do mainly engineering support as well as some advising and consulting with different types of companies like startups and universities. So we have a lot of fun. Where we're both currently located is actually about 45 minutes north of here in Shelby Township. Anyone know where that is? A little bit? Awesome. Well, it's kind of in the middle of nowhere, but we have a lot of fun at Shelby Township. And we are also found in a few other places, including California and Texas. So we're a global company, which means we have different offices all over the world. So if you like traveling, robotics could be a job for you. But the real question is, why are we all over the place? So why robotics, Alexis?
Why robotics? Well, it's an up-and-coming industry. It's exploding like crazy. So this industry has grown so much over the last few years, and we are really, really in need of great talent like the people we have in this room. You're obviously here because you're here for the robotics competition, right? You've got robotics in your DNA, so this could be the future for you, KUKA Robotics, or any type of robotics company. So who is KUKA? Well, let's start by saying KUKA is responsible for manufacturing robotic arms, such as this one, this miniature version in my hand right here. So KUKA is a robotics and automation company. The two guys that came up with this company, these two fine gentlemen on the slideshow right there, Keller und Napich Augsburg, so hence the name KUKA. The U comes from that und, that'll be the only German you get today. That's and in German. So they came up with this company quite a while ago. 1898 is when it all started, but that's not when the robots were first manufactured. They started this company way back then, and they started with oxyacetylene torches. They made typewriters. They made garbage trucks. They went through so many innovations over the few years that they started, and eventually they got to robotics. The first robot that they introduced to us was called the Famulus back in 1973. The Famulus. There's a picture of it right here. Kind of the strange creature right there. Really, it doesn't have 5 arms coming out of it. That's just illustrating its reach, how far forward and how far backward it can get. So 1973, quick math. See, you didn't know you're getting a test today, did you? How old is that robot? 45. 45. We got 45 over here. We've got a winner. That's right. It's 45 years old. As the evolution of this robot took place through the years, you can see the robots have changed and become more modern. Now we're looking at things called the KMR and the LBR-EWA. Those are our most fancy, most sophisticated robots right now. And you saw those robots in the video just before we started. So I'm introducing you to a couple of things here. Maybe it's new, maybe it's not. I 4.0 and IoT, the Industry 4.0 and the Internet of Things. How many people know what that means? Heard those buzzwords before? Anyone? Yes, I got a yes over there. Anyone else? Yes? Great. These are very important buzzwords in the robotics industry right now. So, Industry 4.0. This is talking about the fourth revolution of industry. So you can see through those pictures, it's pretty self-explanatory. Then at the fourth one you see there, it looks like robots with those Wi-Fi icons at the top. You know what those look like because, you know, you all got phones. I know you do. So those robots and that equipment they're talking to each other. They're communicating to the outside world. It's really important that we know what our robots are doing. And they're telling us what they're doing via the internet. Now down below we have the Internet of Things. You see that cloud down there with all those little icons in it. We see airplanes, we see phones, TVs, all these little things in there. And that's representing that those things are talking to the outside world. They're telling us their status. They're sharing that information. So for example, I have a friend who showed me his phone. And on this phone, it was a little message from his dishwasher telling him that the dishes were done. And he was so excited, he's like, yeah, now I'm going to text my kid to unload the dishwasher. Like, that's where we're going.
I would like to also add, just quickly, how many of you guys play things like Xbox or PlayStation? Anybody? Yeah, right? Some good games? Maybe some COD fans? No, not so much? Okay, still like fishing. That's good. So as you already know, you guys are connected to online games via things like the Industry 4.0 and the IoT world. You guys can be a part of that for robotics. We're implementing those type of technologies into robotics, and maybe one day we'll be having video games similar to like you guys are doing now with real robots and things of that nature. So the future is wide open for y'all.
So a little bit more about KUKA, our presence on a global scale. We have offices across the globe. You can see the countries listed down there. There's a few dots up there, the black dots, which are a little bit more special than the rest of them. The black dots in the middle here are representing where the robots are made. So I said in a previous slide, they're made in Augsburg. Augsburg is in Germany. We've got another black dot right close to it, and that's actually in Hungary. So some of the robots are also made in Hungary. And then on the far right, we've got another dot. Okay, here's a geography challenge. Where might that dot be? I heard China, the smart group here. We got some robots made in China. Typically, the robots that are made in China stay in China. The robots that are manufactured in Augsburg, Germany, get transferred all over the world. Our office in Shelby Township receives those robots from Germany and then distributes them across North America into projects, automation projects. Oh, another thing about how many employees. We've got 14,500 employees and growing.
So you can find us pretty much everywhere on different continents and in different places and locations, but we're also in a lot of different companies. Does anybody see any companies that maybe their parents work for or that are familiar on the little symbols on the page? Yeah? Okay, good. Awesome. So as you can see, robotics is in lots and lots of different companies. Coca-Cola, Johnson & Johnson, Intel. We're building computers. We're helping processes for making a Diet Coke. We are doing things with Nestle, IKEA. These are all really, really fun, neat opportunities that robots are being used for. So it's not just games. It's not just for shows, but we also are actually making an impact in the real world. So we have places like automotive that most of you guys know, right? We're going to build a car. We're going to use robots. We're going to help the person completing their task to build something, but we also are even more interested in how we can use our robots in things like the electronics field, or possibly maybe ice cream. How can we do that? How can we help people do tasks more efficiently and quicker? So how do we get here from maybe where you guys are sitting into an industry with working with robotics? Alexis, maybe you can shed some light on this.
Yes, I can, because I'm the manager of the KUKA College. So KUKA College is a training institute where we bring in students such as yourself, end users, customers, and our own employees, and we teach them how to operate robots, work with robots safely, program robots at a very sophisticated level. We teach them how to take care of the electronics and how to take care of the mechanical unit. So in some of our classes, it gets as fun as taking apart the robot completely. That means taking each piece apart, taking a look inside, learn how the servo motors work, how the gearboxes are connected, where the oil has to be placed, where the grease has to go, and then getting that robot all back together, and you get to go home when that robot works again. So here's a few examples of the types of robots KUKA has. You can see from the left all the way to the right, we've got some robots here, and these all have about 6 axes. We call those a 6-axis articulated arm. That's very similar to the one I've got in my hand right here. That means each one of those joints will move together so that the tool center point maintains a straight line. So we've got 6 axes of articulation here. The last one is a 4-axis robot. That one's special because the tool flange, which is that black thing right here, maintains a perpendicular position to the ground, and that's used for palletizing. People want their products to get out the door pretty fast, and we want to get that product off the conveyor and onto the pallet, bam, 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 fast. And by reducing the number of axes, we're able to do that and speed up the process. It's a wicked fast robot. The one on the far left, this is the lightweight robot, which my friend Mitchka here is particularly fond of.
So we're not just interested in moving, or we're not just interested in robots moving, but we're actually also interested in moving robots. So we're coming up with these new designs from a robotic standpoint that allow us to take a robot from one place to another inside of a factory, or maybe inside of a home, or different areas that could use a same robot to do different tasks in different spots. So is anybody familiar with the OmniMove? Yeah? So Omni wheels are a very useful type of tool for moving some object, right? It can go forward, backward, left, right, sideways, spin. It has all these different capabilities. And you might ask, well, how? Why? What is it that allows it to do this? Well, it has some really neat technology that uses different movements of wheels at different periods of time, different speeds, in order to create those type of movements using a very unique structure. So if you move only 2 of the opposite wheels, you could get a left turn. If you move 2 of the front wheels, you get a different response, and it goes on and on. Sometimes one wheel is moving backwards, another wheel is moving forward. This kind of allows us to move really, really large objects in really neat directions. So some of these OmniMoves actually take up entire football fields. Yeah, that's pretty large. And we actually move airplanes on these large structures that allow us to move increasingly larger objects all around a factory for huge companies. We also have KMRs, which are these little guys right here. So there are KUKA mobile robots. These are robots you might find in a hospital or a factory that allow a robot to do a task and then move really quickly to do another task somewhere else, or maybe pick up something and bring it to you if you're like miles away. Just kidding. Can't go that far. But it can go pretty far, and it can work on about a day or 2 of power, and then you'll have to recharge it. We also have some fun things that we're interested in, like the RoboCoaster. This is a robot that actually moves you in space, like you, as in like a coaster, you know? Yeah. Okay, so what we do is we jump on this thing, we get put in just like you would a roller coaster, and it kind of moves through different orientations and translations to make a really exciting time. Alexis, you've actually been on one of these things.
I have. I've been on a few. I've been on the type where there's nothing in front of you, and that was pretty wild. The cool thing about it is you don't see a track, and you don't know where you're going to go, hence the excitement is even higher. I've been in one where there's a hood in front. We have an entertainment company that creates these structures where you're inside, there's a hood, you see a video in front of you, and it gives you the feeling or the simulation that you're traveling through space. So with the motion of the robot in parallel with the motion on the screen, you get this feeling of momentum. In addition, I kid you not, they had a vibrating seat. So it felt like you were actually sitting on a motorized vehicle. There was an option for a plane, and there was an option for, I think, like another roller coaster within the video. and they had a little bit of wind blowing on you. So it was a really, really cool experience. If you get a chance, I highly recommend it.
Now this one is kind of special to you because you think it's really cool. So why don't you go ahead and explain that one as well while you're talking?
Yeah, that one's really cool too. There is a robot inside the jacket here. There's a programmer responsible for teaching a path so that this robot pushes this white part, which is called a occubot. In the field, they like to joke around, call it occubut. But they program this robot to go in and out of the seat. This is a car seat here and here, repetitively, until they see wear and tear on the car seat. So they're measuring how many times somebody can get in and out of their car seat before the car seat falls apart. Now what's even more interesting here is the fact that it has a jacket on top. Why would it have a jacket on top? Any ideas? Huh, that's a good answer, but not exactly.
Anybody else?
He's very close. He's very close.
Great answer.
Great answer. The jacket is to protect the robot from extreme environmental conditions. This robot in the setup is inside of a temperature-controlled chamber, so we can apply extreme heat or extreme cold to the test process. Robots don't like extreme heat and extreme cold so much. They like it just right. So we pump room temperature air into the jacket to keep that robot just at the right temperature for full functionality.
Does anybody have any idea why robots don't like change of temperature? That is correct. And I'm going to give you a pair of headphones because you answered that correctly. Awesome.
All right, what industries are using robots? Industries.
Well, maybe I can shed some light on that. So industries, just like companies, are there. Well, there's a lot of them, right? And with robotics and KUKA, we like to be in as many industries as possible. So you get to see some examples here up on the stage. So wood furnishing, plastics, automotive, medical, aerospace, electronics. We have a lot of different fields that we're interested in. What kind of fields interest you guys? Anybody? Fields? Things that you like maybe would be a part of? Yeah? Medical. Awesome. We'll get into that a little bit later, so you might be excited. Anyone else? Anything? Aerospace, right? Planes, and even going up further, right? Yeah. Anybody else? Yeah? Electronics and solar. Nice. Yeah. PCB boards, right? Yes. Cybernetics. That's a great question. So we would build electronics that are used in cybernetics, but not directly. But still, there's a lot of robotics that are still involved in those type of processes. So again, these are some of the industries we use, but what kind of applications in these industries are the robots used for?
Good question, Mishka.
Thank you.
The applications are used for in each one of those industries could be a combination of these or one individually. So we have welding and joining, palletizing. We have assembly, handling, inspection and measuring is what I talked about on the previous slide. So within those industries, we could have multiple applications. So for example, the automotive industry is an excellent example where they would use robots to do many of exactly these things within their company.
So again, going back to the RoboCoaster because we think it's awesome. Why applications in fields such as this? So how many of you guys have been to Disneyland, Disney World, Legoland? Yeah, right? You guys have fun in those kind of places? Why? Is it exciting? Is it like you're in a fantasy world kind of? Well, KUKA loves to be in those type of environments. We're an exciting company, can't you tell? Come on. We enjoy quite a lot doing things that makes people smile. And so robots are one of those type of things that can make people smile. And when you're on a roller coaster, you can't help but scream and smile, unless you're scared of them, which I completely understand because it can be frightening. But anyway, so we use the technology for a lot of different fields. One of them is entertainment. Another one is the media field. So how many people are maybe interested in marketing or any type of arts? Awesome. Well, guess what, guys? It's not just robotics and engineers and scientists that use robots. It's also people in the media fields or the arts fields. We need people to make robots like these look beautiful. We want them to be easily integrated into lots and lots of different fields. So if you go on YouTube tonight and you're feeling kind of bored, or you're feeling super excited and you want to check out some more robots, Google KUKA. You'll see a whole lot of different types of applications that we use our robots for. Some really cool videos like the one we showed you at the beginning of this, as well as some other applications.
Do we have any ping pong fans here? Ping pong, a few. So familiar with Timo Ball? He's a star. That's the guy that's in the picture there that we can't really see, but that's a promotional video with Timo Ball.
So we're also really interested in the medical field. The medical field brings up a big part of my life, and so that's why we're going to kind of go into it just a little bit today. I just want to show you a different application than automotive that you might get excited about, that robots are being involved in. So how many of you guys love going to the doctors? Nobody. Wow. Okay. Oh, we got one back there. She's like, kind of. Okay, well, I love the doctors. You know why? Because I get to find out information about myself that I might not actually know, right? If I'm feeling bad, they could tell me why. If I'm feeling really good, they can tell me why. If I don't know what's going on, they can tell me what is going on. So what do we want to do? We want to take robots into the medical field to help doctors, physicians, technicians, nurses, PTs, OTs, all these different types of roles in the medical field to do their tasks in a simpler and more efficient way. So robots are a great example of that. Here we have two different ones. One is a cyberknife. Has anybody heard of the Accuray cyberknife? No. Well, let me explain it to you. So the cyberknife is an actual robot, two of them, that are working together. One of them actually has a tool on it that is shooting radiation into a certain cancerous cell. So tissue that becomes cancerous, it doesn't always spread to the entire body at one time, as many of you know. It starts in a small tumor. This procedure allows us to focus that radiation on one spot of the patient. What does this do? Well, it keeps the patient healthy because it doesn't shoot the radiation across all the good cells too, damaging them. It just kills the bad cells. Now you might ask, what is this bed-like thing doing? Can I have one? Well, unfortunately you can't, but if you go to the doctor and you do have to have some sort of treatment such as this, what it does do is it actually takes the position of the patient into consideration and moves it when the patient moves. See, there's a vision system up here. Has anybody used Kinects? Like on their Xbox, right? To do like the Wii games and stuff, or like the Xbox games? Okay, so same kind of technology is used in the medical field. The patient moves left, the bed will tilt right so that it counterbalances and allows the treatment to stay on that tumor. That's pretty cool, right? Come on, anybody? Yay, okay, awesome. And on the right side, we have the Siemens robotic C-arm. What's going on here? Well, in the medical field, imaging is crucial. When you're trying to find out what is going on inside of the brain or inside of some part of the human, what do you need to do? You need to look inside. The problem is the doctors are super busy doing all different types of surgical cuts and making sure that the patient is staying alive. So we use imaging with our C-arm to be very accurate and see an image as the patient is moving and during the actual real-time procedure, which is fantastic because it used to be that you put the patient in a long imaging system, take them out, and then do the surgery, and things can change, right, as we all know. So these are two different types of applications. Alexis, what do you think?
I think it's pretty crazy and awesome.
Okay, now this one gets a little gross. Alexis doesn't love this, so if you don't like this picture, I apologize, but I think this is a really cool application. So this is a dummy. This isn't an actual real person. But what this is an example of bone cutting. So that sounds really gross, right? And maybe to some of you it sounds really cool. The problem with cutting bone or any type of facial reconstruction surgery is that it can be messy, it can be complicated, and it can take long amounts of healing time. What do? We use our robot to do very precise cuts. That allows faster healing time and improves the process as a whole, right? Straighter lines, different geometries. Like, if you think about the face, it's like really complex geometry, right? So how many of you guys know basketball? Simple geometry. What kind of geometry is a basketball? Sphere. Okay, somebody said a circle. I was about to have to take it back to third grade. All right, so a sphere, what type of shape is I don't know, let's see, a trapezoid? Oh, good. Okay, you're paying attention. Awesome. Just making sure. So, as you can see here, the facial structure, the mandala, is actually very complicated and has lots of different geometries in it. So, if you model it, you can get really neat lines. Well, how do you do those really neat lines, you might ask, with a doctor? Well, use robots. So, this is a great application, really neat, really fun. We have a good time in the robotics world. As we move forward, we'll talk about robots working together. So here we have two robots. This larger one is that C-arm type robot that's taking the image. This little one is my baby. I love it. It's great. It's this one right here, just a different type of version called the EWA. The EWA, LBR, lightweight robot. B is a German word. Unfortunately, you're not going to get that one because Alexa said you only get one German word today. But the LBR is a fantastic robot because it's HRC. Does anybody know what HRC means? I'll give you human. That is a good one. I'm going to give you headphones just for answering. Good job. No, it's actually human-robot collaboration. So collaboration is this idea that I get to work alongside of the robot in the medical field. It's really neat. So again, this robot is moving and doing a task on the patient while the other robot is imaging. This is a robo-team. All of you guys worked in teams, correct, over the last few weeks? Did you guys enjoy working in teams? Yeah. Well, so do our robots.
So Mitchka, those robots are working in really close proximity to each other. How do they not crash into each other?
Great question. Well, these robots are actually HRC compliant. Does anybody know what HRC means? Oh, nice. Still paying attention. Love it. We're almost done, I promise. Okay, so human-robot collaboration allows you to use sensors. Does anybody use any specific sensors here for their robots? Yeah? Go ahead. What is it? Ultrasound sensor? Ultrasonic sensor. All right, here's a headphone for answer. Ready? Can you catch? Woo! Oh, that was a fail. Okay, so yes. Anybody else? Any different types? Yeah? Infrared. Awesome. Infrared sensors. Well, we use different sensors such as torque sensors, position sensors, to determine what's going on in the outside world in relationship with the robot. So, for example, if I was to push the robot, it would move out of my way. And it could come back. And if I was to push it maybe a little bit harder, it would stay. And then maybe if I wanted to come back, I could double tap it or something and it would come back. That's all programmable. These are all the direction that robots are going, collaborative. How does it happen? Well, we program it. Similar to you guys. You guys use libraries, APIs. Well, we have specific ones for KUKA that use the foundation level of Java. Has anybody heard of Java? Yeah, awesome. Like, I'm talking about the cup of coffee that you probably all should have drank this morning. No, I'm talking about the programming language. So that's what we use to build the applications for these robots. So they're mechanical, but there's a whole bunch of software in them. Java currently is, it's a good question. Python is actually an industry standard for anything with artificial intelligence. Java is a simple programming language that we use for a lot of robotics. The industry standard is actually a little bit below that. It's usually a custom language built on some sort of very easy, inline programming that makes it really simple to program a robot. Would you guys use a certain language for all of your robots that you guys know? LabVIEW and Java, right? Which are very common in the world, right? Android uses Java. There's a lot of different type of applications. Oh, So this is kind of like the last medical slide. We just have a little technician working with our robot, changing the tool, showing that we can have this HRC work environment, making it really easy to do surgeries because you're just changing different devices on a robot who can do all the different tasks that you need it to do.
So thinking back to like a standard application in the automotive industry, robots are super dangerous and they have guarding around them to keep the people out and everybody safe. I don't see any guarding here. Does that relate to the HRC thing? Like, how is that guy not getting hurt?
That's a great question. So when you program a robot, you guys have to give it certain tasks or certain things to expect. Well, we do the same thing in our robots in the medical field or in any field. If we're boxing ice cream up, we tell the robot, hey, maybe look for the barcode, figure out if it's chocolate or vanilla, and do something based on that. Now, we're taking it to the next step in the medical field by making sure that the robot, in any situation, no matter what's going on, can actually rely on the information that it has to not hurt anybody. This is where buzzwords like AI or machine learning come into field. So we try to use, new companies are trying to use our robotics with these types of technologies to do really, really neat applications. Oh, okay, we have one more. This is quick, promise. So this application is a biopsy from a spinal view, so like the back, which is pretty cool. And as any of you know, the spine is extremely vulnerable, right? The spinal cord, if you even just cut it a little bit, you can lose all functionality of your body depending on where on the vertebrae you actually cut. So what we need is highly precise, highly accurate machines to do these type of work. So our robots can actually get up to like 0.1 millimeters of accuracy, which is pretty good if you're in a kind of situation like this. And it can get even better if you have the right technology surrounding the robot. So Alexis, talking about all this applications, how does that look in the industry? What type of jobs might that bring about?
It's all about STEM jobs. And I know a lot of people are hearing also the buzzword STEAM. Add the A in there. The A is also very important. We just left it out of the slide. But A, meaning the arts, big part of it. But these are the types of jobs or the types of positions that we look for robotics employees. Of course, the first one up there is the robotics engineer. I studied robotics and automation, mechanical engineering. My friend Mitchka has a different background, but very, very useful within the robotics field. What classes would you take? I think it's all pretty obvious. We're looking at a lot of science-based classes here. Don't forget the arts. The arts are also very important, just in the fact that somebody had to design the castings on this. So you have a mechanical engineer who designs for structure and integrity, and then you have somebody else who says, yeah, that thing has to look slick. It can't look like just an ugly, boxy piece of equipment. Let's make it look super cool. What degrees can prepare you? We're looking at electrical engineering, mechanical, computer sciences, computer programming. Kuka Robotics especially looks for a lot of people with electronics background and programming background. Our parent company in Germany, they're looking for people who have mechanical especially and computer programming. So yeah, as long as you stay in this field, you're on track for a career in robotics.
So you might ask, well, what kind of colleges might I be thinking about if you want to go into the robotics world? Well, we just listed a few here for you that have undergraduate degrees in robotics. These are really cool to check out if you have a second and you want to see maybe if robotics is an interest to you and you want to start out that way off the top. These are a few schools that might give you intro into those type of classes. Now, as you can see, our presentation was about robotics, robots, KUKA. So just let's do a quick summary and then we'll do questions. Does anybody remember the name of one of the robots that we talked about? The Fabulous. Fabulous. Okay. Yeah. Yes. Great job, man. All right, anybody else? One of the robots.
Okay, we need.
Okay, maybe we'll switch questions a little bit because I think everybody's hand's going up now. Let's see. Do you have any questions? Okay, no. Let's see. Why is it that our robots can work with people? Way in the back. Yes, we'll give you this one. Actually, we'll give you the collaborative one since you say collaborative. Here you go. All right, we need one more good question. Got
Good
anything?
question. Um, Automotive?
Automotive, okay. Something about automotive. Can anybody name a company that KUKA Robotics might work in? Oh, that's a lot of hands. You can pick this one.
Bumblebee.
Intel.
Intel's on the list.
Intel's on the list.
But that's not automotive.
It's okay. Whoa, relax, Alexis. She's doing great.
She's doing great.
All right, awesome, guys. That's enough
Yeah.
questions. All right,
So-
anybody have questions for us?
We got one over here. Yeah, that's a big topic.
Yeah,
Very
that's
big
huge.
topic. So what the robotics industry supports the need for skilled workers. So there's two aspects there. The robots are supplementing the workforce by providing those helping hands. The robots are also there to take out a person from a poorly designed, like bad ergonomic situation. You know, imagine that you get this fabulous job at an automotive company and they say, yeah, we're going to pay you a lot of money, but all you have to do is this. For 10 hours a day with maybe 2 breaks. Wow, you would have a really strong left arm. So that robot would then be taking away that poorly designed ergonomic situation. The other thing is, robots are actually creating jobs. So for every robot that you see out there, there's actually thousands of people behind those robots. There's the designer, the mechanical, the artistic designer, the mechanical designer, the electronics. There's people designing and improving the software. So it expands just astronomically. So then once again, behind those robots, there are thousands of people with jobs to support those robots. Once those robots get into the field, you can't just leave them alone. It's not just about integrating a system and walking away. Those robots need constant maintenance. They need supervision in a sense. You can't just leave one and expect it to run forever. Robots are robust and they don't take breaks, that's great, but you still need a person to take care of those robots because they do stop. And that comes back again to the industrial revolution and having your robots communicate with the people. We have to know, did the robot break down? Why is the robot stopped? How many parts has it produced that day? And does it need maintenance at any point?
Awesome, Alexis. Thank you so much. Any other questions? Yeah. Of course. Like photography, videography. We use artists to design animation with our robots. So there's a ton. There's a ton.
Yeah, it comes before and after. So in the design and creation phase of the robot itself, you have designers that create the models. And then after, in the applications phase, you get them used in cinematography, movies. A lot of movies are actually using our robots. I don't think I can tell you, but in cinematography after. So there's before and after uses of the robots. Yeah.
One behind you because she's been having her hand up a bunch. Oh yeah, there's actually this application that just came out, super awesome. They're using a robot to do cooking. What? Could you imagine like waking up in the morning and a robot's like, hello, here's your coffee. And then, shh, here's your cereal. So yes, they are. You had one?
You want to talk about
Yeah,
that?
sure. So all of our motors are servo type motors. We use harmonic drives as one example. We have quite a few of different types of technology in the robot. But yes, every axis itself has multiple electronics and motors that work to motion that axis. So there'll be harmonic drives, for example, servo motor, these electronic boards that actually control how much amps are going to the motors. Yeah, does that kind of answer your question? Okay.
Why is the EWAS so special, though? That one has like got some really crazy
Yeah,
tech inside it.
we have a lot of different things. So every axis on the LBR EWA, which is a smaller robot that's collaborative, is dual monitored. So for every type of sensor, we have two of them. So if we had a position sensor, we have two. If we have a Hall effect sensor, we'd have two. So, and they're all measured on the actual output shaft of the motor, which may mean nothing to you guys, but basically that means it's super accurate. Anybody else? Questions? We love questions. Uh-huh. Yes, and where, do you even know where that is? Saudi Arabia. Great, yes. So what do we do with these humanoids? I think they're called humanoids. Is that right? Anybody know? Yeah? Yeah, okay, good. I'm smart. Yay. Okay, so humanoids. Great question. How does that play into the role of KUKA? Well, right now, it doesn't. We're not there yet. But could it? Definitely. How does that play a role? That's a really good question that I'm not going to answer because I really don't know the correct answer. And it's okay not to know the answer all the time. Alexis, do you know the answer to that one?
In terms of KUKA, we take more industrial approach to robotics. So we're looking at how to assemble things, how to create products easier, how to get products or different parts from one place to another. KUKA isn't really focused on the humanoid aspect of robotics.
But I would say we love looking forward, and we might be one day. But for different things like industry, I don't think you're going to see that right now. Maybe in 5 to 10 years, and there'll be a lot of opportunities for that type of technology to be used, such as the Watson. Have you heard of Watson? Anybody? Yeah, right? It's this really smart computer that beat 5 doctors on a task of determining what the condition of the patient was. And then the doctors ended up doing what? Do they disagree or agree with the robot's decision? Agreed. Great. Awesome. You had a question. You can have that one.
Okay, the competitors. So you know who our competitors are then? A few? Throw them out there. Yeah, okay, so we got ABB, Fanuc, Yaskawa. There's a lot of other robot companies that have 6-axis articulated arms or something very similar to what we sell. The KUKA robot is a particularly special robot because of its open source platform. So a lot of our programmers really enjoy working with the software that we provide with these robots because it allows them to dig in and do a lot of really specialized things. The other robot companies provide software where it's more modular. They pick out pre-canned instructions from an instruction list. So programmers get really geeked up on this. The other thing is the rigidity of the robot. This one is able to do path performance that is greater than our competitors. The accuracy is much higher, the repeatability is much higher, especially with the EWA robot that Michka uses. And especially since it's used in the medical field, it has to have that incredibly high repeatability rate and accuracy rate. So those are 2 examples of why ours are super special. We also have about 300 robots in our product line, which gives a lot of flexibility for our customers to pick which robot best suits their application. And why do we have so many? Because they come in all shapes and sizes. And you want to buy the one that fits in the cell. These cells are not wide open like this room. There's a ton of guarding around it. There's conveyors. There's other structures around, big other equipment around. Therefore, the space for these robots is very small. So because we offer a lot of different models for our customers to choose from and payloads to go with it.
That's awesome. Great answer. Yes. Cost. Great. Maybe we can talk after. No, I'm just kidding.
How many do you want?
Yeah, it all depends, right? Every robot's going to cost something different, and it depends on what your interests are. So there's a lot of different companies that have different price points. So a robot could cost anywhere from $15,000 upwards to $80,000 or $90,000. So we have like a really, really wide range, and more expensive, of course, if you're trying to move like entire cars and stuff. But I'm just giving you a rough estimate of what robots in the industry cost.
Yeah, it also depends on what kind of software packages you add, what kind of energy supplies you add, because energy supply means how do you get the messages from your computer to the end of the robot. Those messages being, to open and close a gripper, turn on valves, look for a part that's present, and all that stuff adds up.
Go ahead. I think like overall we're involved in a lot of different automotive fields. Whether we can say like one or not, there's some like discrepancies with just legal stuff. But I will say that we are in the car industries, and there's a lot of our robots in the car industries. So I can't tell you exactly which ones.
The question was, does Ford use our robots?
Yeah, and that's
Are
what
we
I'm saying.
allowed?
Yeah. They're a great company to ask that question to. But we may be, we might be. We are in a lot of different automotive fields. So that's all I can say. Sorry. Any other questions?
When you get, just one side note, when you get into the automotive industry, the most amazing part of that is that they buy in the thousands. So you can imagine this robot, it's very large in the real life, in the thousands. So when you go to an automotive plant and you look down the lines and you see all these robots working together, it's like seeing these amazing creatures just go and doing their jobs. It's a really cool sight.
Yeah. All right. Last two questions, or possibly one. Yep. Great question. So, do you mind if I take this one?
Sure.
Okay. So, in Germany, our robots are built on like manufacturing lines, right? So, all the same robot, all the same type of ways, but we have the ability to paint them different colors, and there's a lot of different combinations that we can put together to build a robot. So you might use different power supplies, or you might use different types of grippers, or some come without grippers, or we have 300 different types of robots, so we might be able to find the robot you need. As you move into the more detailed, more collaborative robots, such as the LBR group or the mobile robot platforms, well, it gets a little bit more complicated because a lot of these parts are actually all done at once. So like all of the maybe elbows are done, and then they're combined with another part. So it gets a little bit more tricky to do like really, really intimate design work. But yeah, there's a lot of different options there.
Yeah, for customization, what we do is we look at the application, and it's all about reach and payload, and then the floor space in which you have to place the robot. So we look at payload. Is it going to be a 16-kilogram payload, 50-kilogram payload, etc.? And then we always aim higher. And then we look at reach. How far do you have to go to place the part, etc.? And then we look for the right model to fit the application. So as far as customization of robots, not so necessary, I guess, because we have just so many to choose from, and there's always going to be one that fits the application that you're trying to fit. And then as Mitchell said, there's some variations you can get there. You can get the paint a different color. You've got robots that are green, blue, a lot of red ones. A lot of red ones.
Yeah.
In sunny California.
In automotive. Yeah. We do. Did you remember the KMR, the Kuka mobile robot, with the EWA on top of it? That's actually in our facility in Germany right this moment, doing tasks to help build robots. But we also have some on the line that are helping build different types of things. Yeah. All right, I think we are out of time. How much time do we have left? 7 minutes. Oh, wow. Okay. Well, we'll probably end a little early, but if there are any other questions, anybody? Yeah. Yeah, so that's a great question. He literally just asked that question, but hey, you're on the same page, which is a good thing. So yes, we do. The KMR thing moving around in Germany, yeah, that.
But we don't use our competitors' arms. We don't use the competitors'
Wait, are
arms.
you telling me we don't?
We don't.
Really?
No, we don't.
Oh, okay.
Because ours are the best.
That makes sense. But if a robot builds another robot, and that robot builds a robot, isn't that robot better than the first robot? Okay, good point. All right, well, I think we're going to close there today. Thank you guys so much for coming. Alexis, Michka, great to see you guys.
Thank you.
Have a great rest of the time at First.